Somewhere in the ocean right now, more than half a mile below the surface, something is floating in total darkness, with its mouth wide open. It hasn't eaten in days. It hasn't moved in almost an hour. Its teeth are so long they don't even fit inside its own head, so they curve back past its eyes like two permanent exposed daggers. And it is waiting. Not hunting, not chasing, waiting. Because down here, in a world with almost no food and no light, movement is the one thing you cannot afford to waste. This is the viperfish. And if you think you already know this animal because you've seen a thumbnail of it online, I want you to forget that for the next few minutes. Because most of what gets repeated about this fish is the same recycled trivia. Big teeth, scary face, lives in the deep sea. That's it. That's usually where the story stops. But the real biology of the viperfish is stranger, and honestly, more impressive than the scary monster version most people have in their heads. Scientists have only recently discovered that this fish's skull does something no other fish skull is known to do. Its teeth are see-through, made of a material engineers are now studying to build better glass. Its hunting style burns almost no energy at all, because in the deep ocean, energy is the most expensive currency there is, and it survives crushing pressure that would kill you in seconds, using a body that is almost entirely made of water. So let's actually go there, down past the point where sunlight disappears, into the world of the fish with a head full of teeth. To understand the viperfish, you first need to understand where it lives, because everything about its body is a direct answer to that environment. Viperfish live in what scientists call the mesopelagic zone, sometimes nicknamed the twilight zone of the ocean. This band of water typically starts around 600 feet down and can extend past a mile in depth, depending on the species and the region. Some individuals have been recorded far deeper than that, down toward 3,000 feet or more, in near-freezing water with almost no trace of sunlight left at all. At those depths, the pressure is immense. Scientists studying the Pacific viperfish have measured hydrostatic pressure at its deepest range exceeding 150 times what you feel at sea level. A human body brought down there unprotected would be crushed almost instantly. The viperfish survives it the way many deep-sea animals do. Its body tissue is mostly water, with very little dense muscle, protein, or fat, sometimes estimated above 96% water. That sounds fragile, but it's the opposite. A body built mostly of water doesn't compress under pressure the way an air-filled or dense muscled body would. It's an elegant, low-cost solution to one of the most hostile environments on the planet. Now let's talk about the feature everyone actually clicked on this video to see: the teeth. The viperfish's teeth are long, needle-thin, and permanently exposed even when its mouth is fully closed. That's not a design flaw. The teeth are simply too large to fit inside the mouth at all. The two largest fangs, on the lower jaw, curve backward and upward, passing close to the eyes, almost like exposed tusks. When the jaw closes, all of these teeth interlock into something scientists have compared to a cage. If prey ends up caught inside that closed mouth, there is genuinely no way out. The teeth aren't designed to chew, they're designed to trap. Here's a detail almost nobody outside of marine biology circles knows. In 2009, researchers examining the structure of viperfish teeth found that they contain something called dentin tubules, microscopic channels running through the tooth material. Interestingly, when other scientists later examined the teeth of a related deep-sea dragonfish species, they found those teeth lacked these same tubules entirely, even though the two fish are closely related and both have needle-thin, glass-like fangs. Researchers still don't fully understand why one evolved this internal structure and the other didn't. It's one of those small, quiet mysteries in ocean science that never makes it into general animal facts articles because it doesn't have a dramatic answer yet. It's simply still being studied. And that word, glass-like, isn't just a description. Some deep-sea fang teeth are genuinely translucent, almost transparent in certain light, which is likely another form of camouflage. A visible white tooth would flash like a warning sign in bioluminescent light. A transparent one doesn't. Here's where things get genuinely wild, and this is very recent science. For a long time, people assumed the viperfish, like a snake, could unhinge its jaw to open impossibly wide. Not quite accurate. In February of 2017, researchers working with the Smithsonian's National Museum of Natural History, using specimens pulled from collections around the world, discovered and formally described something never documented in any fish before: a genuine, flexible joint connecting the skull to the spine in barbelled dragonfishes, the family that includes the viperfish. This joint lets the head hinge backward and upward at the same moment the jaw drops open, creating a combined gape that can reach up to 120 degrees, wider than any other fish skull is known to achieve, by any mechanism, anywhere. It's a documented evolutionary structure that simply went unnoticed until museum specimens were re-examined with fresh eyes. That gape lets the viperfish do something remarkable for its size. It can engulf prey up to 60% of its own body length, and its stomach can expand to hold prey that is 20 to over 50% larger than the fish itself. Researchers examining whales stranded on the Canary Islands have also found viperfish remains inside pygmy sperm whales and Gervais's beaked whales, deep-diving species hunting the same Twilight Zone waters. So this fish that looks like the final boss of the ocean is really just one link in a long chain. Reproduction in this species is still one of the genuine unknowns of marine biology, which is remarkable in an age when we assume science has documented everything. Because viperfish live at such extreme depths, almost no one has ever observed their mating behavior directly. Researchers currently believe adults are largely solitary, releasing eggs and sperm into open water with no pair bonding and no parental care. The young are on their own from the start, growing up fast in an environment with zero margin for error. Even the fish's name carries a piece of history most viewers have never heard. Sloane's viperfish, Chauleotis sloanei, was formally described in 1801, named after Sir Hans Sloane, an 18th century physician and naturalist remembered today for popularizing a recipe for drinking chocolate with milk in Europe. His real legacy, though, is his enormous personal collection, over 70,000 items left to the British public after his death, becoming the founding core of both the Natural History Museum and the British Museum in London. So one of the most alien-looking predators in the ocean is permanently named after a man better known today for chocolate and museums than for fish. And the genus name itself, Chauleotis, comes from ancient Greek, roughly translating to open-mouthed teeth, a name that was clearly chosen by someone who took one look at this fish's face and decided no further explanation was necessary. So what do you actually take away from an animal like this? The viperfish isn't dangerous to humans, and it rarely, if ever, encounters us, living its entire life in a pressure zone we can only visit with specialized equipment. It isn't even the biggest predator in its own habitat. What makes it worth studying isn't ferocity, it's efficiency. Every part of its body, the transparent teeth, the shock-absorbing spine, the hormone-controlled lure, the recently discovered flexible skull joint, exists because evolution had to solve one brutal equation. How do you survive, hunt, and reproduce in a place with almost no food, almost no light, and pressure that would instantly kill most life on Earth. The viperfish isn't a monster, it's an ancient, elegant answer to one of the hardest environmental puzzles our planet has ever produced. And somewhere right now, one is still out there, motionless in the dark, mouth open, waiting.